One of the most common problems you might encounter when training machine learning models is having badly scaled features. This is when features have very different characteristics and can cause the data to be so confusing that even you won't be able to make sense of it. So one of the most common solutions is known as feature scaling, where you shift all the features to have the same ranges. This will often give you a significant boost in performance. That's why in this video, I'll show you how to implement not one, but two fast and simple feature scaling methods that you can use right away. These are standardization and min-max normalization. And if you're new to this channel, in this series, I show you how to solve some key machine learning coding problems, and we're going to use deepml.com, which is a great website with lots of good machine learning coding problems. And as someone with over 6 years of experience in machine learning, I think I can provide some insights to help guide you through these problems. Okay, let's dive in. So let's read this problem together. So we need to write a Python function that performs feature scaling on the dataset using both standardization and min-max normalization. The function should take in a 2D array as input, where each represents a data sample and each column is a feature. And we need to return it. We actually need to return two verbs, one of them scaled with the standardization and the other using min-max normalization. So let's look at the example. So the data is given as a 2D array, 1, 2, 3, 4, 5, 6. And here we have the two outputs. This one is with standardization, and the second one is with the min-max normalization. Now, I actually have done both of them many times in my machine learning projects. In different situations, you'd want to do different things, but these are both very common. Have you also done them in your machine learning projects? If you did, leave a comment below. We can take a little bit of a look over here. They formalize it. When we do standardization, we actually subtract the mean and divide by the standard deviation. And with min-max normalization, we subtract the minimum and divide by the entire range, which is the maximum minus the minimum. Does that make sense? So let's get into the code here. Our data is going to be a 2D array of size number of samples by number of features. And what we need to do is calculate all kinds of things, such as the mean, the standard deviation, the minimum value, the maximum value, all kinds of things about our data, but we only want to do them for each feature. So we want to calculate, for example, the mean over all the samples, but we want to have a unique mean for each feature. So the way we do this in NumPy is we do .mean, and we just tell it axis equals 0. So this is the 0th axis. And that means we calculate the mean over all the samples. And this will give us something of size number of features. This means that each feature will have its own unique value. First of all, let's calculate the standardized data. So here we do data minus mean. Again, we want a unique mean for each feature. So we do axis equals 0 divided by the standard deviation. But again, we want a unique standard deviation for each feature. So we just need to do the same thing. Axis equals 0. And that's that. We actually don't need this axis in a keyword. We can even just do this, but it's not as readable. So I like to keep it like this, so it's clearer what's happening. But it'll do the same thing. Now to calculate the normalized data, the min-max normalization, what we do is subtract the minimal value, so the min, and now we need to divide by the full range. And I'm sure that at this point, you can already guess exactly how I'm going to do this. So I'm going to take the maximum minus the minimum, and again, I just tell it, these are the axes that I want. And these things I actually didn't need. So all this is actually only 2 lines of code. So I added now import numpy as NP, and let's see if it passes the test cases. And it does. Very nice. So hopefully you learned something. Main thing to remember here is how we calculate the mean, the standard deviation over different axes, and that we want a unique mean, standard deviation, minimum, maximum, whatever you want, but a unique value for each feature. Hope you enjoyed this problem, and check out the next video on how to implement a sigmoid activation.